Yeah. Hello and good morning. Welcome to a nice sunny Friday morning. We are going to talk about the NextETRUCK DAF UK pilot, and we are celebrating our little online kickoff today. I will give a brief introduction and then I will hand the floor to my colleague Louis Jones from DAF UK.
Let's wait maybe a few minutes that participants can join. I see some people
Yep,
are joining already.
I see that as well. Yeah. Okay. So basically, a couple of instructions. If you have questions, please state them in the chat. And the webinar will be made available on our NextETRUCK YouTube channel. My name is Niklas Manolz. I'm working for POLIS Network, and I will give a project introduction. And as I was mentioning before, we will hear from Louis Jones from DAF UK about the DAF UK pilot. That's going to be very interesting because these are very brand new information for us as well. Yeah, if you have any questions, please state them in the chat. So I'm the comms manager of NextETRUCK. So in case you have any interest in form to collaborate, please let me know. If you would like to participate in upcoming events, or if you would like to have another webinar with us, and if you have interesting things to share, please let me know. So what is NextETRUCK? It stands for Efficient and Affordable Zero Emission Logistics through Next Generation Electric Trucks. So as usual for Horizon projects, this is quite a mouthful. So we have the three trucks that you see here on the right, the F-Line truck from Ford Otosan, then the Barcelona waste truck, which we have visited in a project kickoff, and the upper one, the one from Ford Otosan, we've also visited at the ITS Congress, and now we have a virtual kickoff of the third pilot, the truck that you see on the bottom. We probably will see a couple of photos from Luis later. So why is this important? Basically, as the representative of Polis that is taking care of sustainable urban mobility, we see here two photos from Brussels. And we basically face the challenge, okay, do we either want to have attractive high streets like on the bottom, how it looks nowadays, or if we want to have accessibility, how it looked before the huge transformation of the inner city of Brussels. So if you want to have attractive high streets, this can only be done if trucks can bring goods into the city and use the streets to deliver. But this can only be done with medium-sized vehicles because otherwise it might look like this. So here I have examples from mostly the UK and also Italy. I'm not judging the the OEM that you can see here, but it's just mostly accessibility issues. It's not that the truck is too large, but the city is too small. So we need to have the right sizing of the vehicle basically in many of our European historic city centers. And so medium-sized vehicles are perfect. So basically, what are these vehicles all about and what is the project all about? We have 19 partners and we have started in July a couple of years ago, and we're going to end in September. And of course, it's a Horizon Innovation Action. So the optimization of these medium-sized electric trucks are basically done through three elements, which are the component level, where you have the powertrain and the charging infrastructure. We have the vehicle architecture, where we're trying to shave off some weight and also reduce the cost of production and therefore reduce the total cost of ownership, but also have some flexibility when it comes to size. And the OEMs, the different OEMs that we are working with are finding different solutions there. And then also the ecosystems are important. So how do we integrate electric trucks into mixed fleets where we still have ICE vehicles, and how are we dealing with the charging strategy? Um, our objectives that were based from the grant agreement that was drafted many years ago stated this: we want to have a 200 kilometer of daily operation. And nowadays, this is not so complicated anymore, but we basically were a little bit overtaken by reality, and the industry has worked very, very well. And so this is fairly achievable, but also we want to have at least 10% of energy efficiency increase in comparison to similar vehicles. But we also focus a lot on the TCO and LCA modeling, and we have created tools for that. Um, so here I've created a little overview. Our innovative elements are the drivetrain technology, the digital twins that we have developed. We have optimized the vehicle design. Of course, some of these pilots did more of specific elements, some did focus on other topics, and the cost calculation of the fleet overhaul, which is, of course, tremendously important for our shippers and the freight companies. And since Luis will present this element, especially because he is supporting one of the freight companies that looks at this transformation. So here, a brief overview. We are looking at, by enhancing the drivetrain technology, we're looking at utilization of advanced materials and where to place the batteries, but also we are trying to improve the thermal management systems to increase the lifespan of the vehicle and also the reliability. For the UK pilot, this is probably less of a problem because we don't have a huge temperature amplitude, but we are also testing in the mountains of Turkey, and in Barcelona, we've also tested where we have hot and cold temperatures. And since we are testing over a period of 6 months, we also see seasonal changes, which is very important to see how the vehicle reacts and how to gather the data points. And the development of digital twins, there we mainly want to we want to get insights into the energy consumption of the fleet, and the development already took place. And then the vehicle design, this is basically also very interesting for our Barcelona case, because there we have tested a fully electric uh, waste collection vehicle, and this is basically a solution that is already market ready and will continue to play an important role. Especially, I could say that from the perspective of the cities, where the cities need also solutions to electrify their municipal fleet, and of course for the elements of the DAF UK pilot. This will be explained by Luis. And the cost calculation tools, we basically worked with our partner Zenex Netherlands and Zenex UK, and they have several tools that will also be presented in future webinars, which I will come to in a minute. And so here I will not really talk much about the pilots, but we are basically focusing on the third one. And because the Istanbul and the Barcelona one has already launched, as I was previously saying. And here is a very brief overview of the innovative aspects and where and how we're going to use this. And what comes next in the project cycle, basically, we are doing the webinar series where we talk about the all the elements where we cannot organize physical meetings anymore, mainly due to our project cycle, but also to the fact that we've already had many of the physical engagements, but we still want to continue to work with you and to exchange with you. And that's why we have the UK pilot launch today, followed by the Xenix calculation tools that I've already mentioned. And then we talk about the Barcelona pilot results in early June. And then we even going to have a digital breakfast with some German partners of the industry. And basically the all accumulating event, which is going to be the NextETRUCK final conference that is going to take place back to back with the Connecting Europe Days in Brussels. And there we have rented a nice venue, the Academy Palace next to the Royal Palace in Brussels. So if you are in the Benelux, or if you would like to travel to Brussels for the Connecting Europe Days, please keep this in mind and scan the QR code or visit our website. And yeah, don't forget to engage with us on our website, nextetruck.eu, or follow us on LinkedIn. And with that, I will give the floor to my colleague Luis, who will introduce the pilot.
Okay, thank you, Nicholas. Thank you for the introduction. Good morning. Still morning, everyone. My name is Lewis Jones. I'm the EV and Connected Services Director for DAF Trucks UK. And it's my pleasure to walk you through who DAF are to begin with, and our involvement in the NextETRUCK project, and specifically some of the objectives that we are looking to achieve over the course of the next 6 months or so. So I will start a little bit just with who DAF are. So hopefully DAF are a company that are known to you, but just in case we aren't, then we are a European truck manufacturer. We have been building a wide range of commercial vehicles, some of which you can see on the picture on the screen, that have been through a vast number of technology changes over the previous decades, from steam engines to very early electric vehicles many decades ago, to petrol engines, diesel engines, but most recently over the previous couple of decades, more focused around emissions reduction and specifically zero emission vehicles as well, which brings us to the exciting project that we are now involved in. Just in case you didn't know, DAF are part of a wider organisation called PACCAR. So PACCAR are a umbrella organisation, that an American organisation that owns 3 truck brands. So we have Kenworth and Peterbilt, who are predominantly based in North America. So the North American market, as well as some other markets around the globe too, as well as of 1996, DAF predominantly focused on European markets, but also some South American markets and other markets around the world also. As you can see, we have a number of manufacturing facilities around the globe. The predominant HQ for DAF Trucks and predominant manufacturing facility is in Eindhoven in the Netherlands. As you can see there, over 1 million square meters, a huge facility. We also have a cab and axle factory in Westerlo in Belgium, where we produce our own cabs and axles. However, very proudly for myself, as someone from the UK, we also have an assembly plant here in the United Kingdom at Leyland in the northwest of England, where is the only facility for DAF Trucks that produces every vehicle type, most prominently the XB, which is the vehicle part of our demonstration for the NextETRUCK project, which I will go into in more detail, where we serve the majority of the left-hand road markets, such as the UK, but also a number of other countries around the globe, where we build vehicles here in the UK and sell them to the UK. And we also have, as you can see on the bottom there, Ponta Grossa over in Brazil, building a number of DAF vehicles also. So here in the UK, just to give you a picture, we have close to 150 locations all around the UK serviced by our dealer partners, which means that wherever a DAF vehicle lands and is into operation within the UK, you are within a very close proximity to your nearest dealer partner, because that is very important here in the UK, because unlike the majority of other markets around the globe, a commercial vehicle or truck specifically in the UK needs to be serviced and maintained on a regular cycle rather than once every year, as it is, roughly in mainland Europe. Here in the UK, the majority of trucks need to come into the workshop every 6 weeks or 8 weeks, or maybe a little bit longer as well, which means that we need to have a big presence all around the UK to ensure that we're supporting our logistics partners and haulage operators with brand new facilities where they can bring their truck in and have it turned around very quickly. And that is another key component of our electrification journey, because we need to work with our dealers to ensure that they are ready to service electric vehicles, whether they have the trained technicians, ensuring they have the appropriate facilities, and ensuring that they also have the right tools and personal protective equipment also to safely work on electric trucks. So the trucks themselves are a big component of our journey to electrification, but also ensuring that our dealer network are trained up and able to work on electric trucks is also a big component of that also. And also here in the UK, we very recently were proud to announce that we had 30 years of consecutive market leadership, which is actually now 31 years. So a lot of that is down to our production facility here in the UK and being able to support our customers with UK and British production and assembly. And again, it's, I guess, almost a reminder to ourselves that the majority of the trucks that got us over the last 30 years to that market leadership position have been diesel vehicles. However, for the next 30 years and beyond, then the majority of, or the percentage of the vehicles that we will build and register will increasingly become electric vehicles as well. So it's a good reminder of ourselves to focus on this increasing adoption to zero emission. I thought I would also very quickly touch on this slide. So, aside from some of the kind of reasons for moving towards zero emission that Nicholas touched on earlier, around, urban access and CO2 reduction, we as manufacturers have a number of targets for CO2 reduction. And the most prominent one, really, both here in the UK, but also in mainland Europe, is something called VECTO, which is the Vehicle Energy Consumption Calculation Tool. And the upshot of that is, using 2019 as a baseline year, we need to demonstrate increasing reduction of CO2 of the vehicles that we build and register, both here in the UK and also in mainland Europe. So for the year that we're currently in, that target is 15%. So we need to demonstrate 15% reduction of all the vehicles that we register versus the vehicles we built and registered in 2019. And that will increase as we then head to 2030, and then again and again beyond that also. So from a manufacturer perspective, that is a big driver and really supporting us on our journey to focus on zero emission trucks and electric trucks, and ensuring that the business case and the technology is right to work with our partners to get these electric vehicles into the marketplace. Also, specifically in the UK, there are currently end of sale dates for non-zero emission trucks. So in 2035, that is the current UK government's commitment to phase out non-zero emission trucks up to 26 tonne gross combination weight, so total vehicle weight. And 2040 is the current UK commitment for any trucks that are larger than 26 tonne. There is a consultation currently in the UK going on with government around putting some of these targets and dates into law, into legislation. However, at the moment, they are kind of commitments and regulations, and they prove as a good target point for manufacturers, but also as for operators to target reducing CO2 from their fleet and move into electric trucks. So moving now more specifically onto the NextETRUCK project itself and what we are trying to do here. So a couple of years ago, DAF UK worked with Cenex, who are also supporting the NextETRUCK project with a trial called the Battery Electric Truck Trial. This was with our first generation of electric trucks, our LF product, which is a picture of which you can see on the screen. And this is where we deployed 20 electric LF 19-ton vehicles across the UK to a variety of operators, the majority of which were NHS, so National Health Service, like hospitals and local councils, to work with them to put electric vehicles into their fleets, and also, most importantly, to then report on the data, some of which you can see on the side of the truck there, but I will go into that in a little bit more detail on the next slide. So this trial was fantastic. All of the data is publicly available, and on the next slide again, which I'll go into, the website is there where you can go and view some of that data yourselves. And the purpose of that really was to take a real first step on electrification with real operators doing real loads, doing real work, just to really see how these vehicles worked in the real world. And it was a really good moment for us to take that first step. So I've touched on some of the key points that we learned through the battery electric truck trial, which you can see on here. So we covered close to 290,000 kilometers over that 2-year period, with 275,000 kilowatt hours of energy consumed through that period. And the range numbers, as you can see on there, so the range kind of extrapolated out to a full charge. The average was 270 kilometers, with a split then of the road conditions. So for rural operations with lots of stop-start, you've got rural, 303 kilometers. You've got 226 kilometers for urban, and then higher for motorway driving, so 292 kilometers. We had some daily distance travelled statistics as well. So the average was 95 kilometers, with the maximum with some charging taken into account being 573 kilometers. An average state of charge consumption of 39%, and then utilization there as well. So, roughly 2 hours and 3/4 of driving per day, and just over 2 hours of charging per day. So there's lots more data that you can see using that URL in the top right there, so bet.cenex.co.uk, and you can view that information and go into that in a little bit more detail, because the purpose, again, this was supported and subsidised and funded, was to make all of this information publicly available so that other operators could get a understanding of electric trucks and why they might work for their operation as well. So a really good kind of baseline with our first generation trucks, and ultimately, which I'll come on to, the NextETRUCK is the next phase of that. So with our new vehicles, how can we take some of those learnings from the BET trial, and advance that with new technologies and kind of push the vehicles further. So that brings us on to our 6-month demonstration. So we've got 3 key objectives that we would like to achieve through the pilot. Number 1 is to demonstrate the efficiency improvements we've made with our XB product versus the LF product that we used in the BET trial, which I will go into in a second. We are lining up with the NextETRUCK objectives that Nicholas talked about. We would like to evidence total cost of ownership parity for electric trucks versus diesel, again supporting the mass adoption to electric trucks and proving to operators that taking this step can evidence a real total cost of ownership benefit. And thirdly, which is one of the key factors of the demonstration itself, is to understand and test what are the key factors that influence vehicle efficiency and how much of that range and battery availability you can achieve through the pilot, whether that's a driver or other factors, which I will touch on. So, as I mentioned, we used our old phase 1 kind of product, the DAF LF, for the BET trial. And since then, we have been working on a whole host of new fully electric DAF products as part of our new generation DAF range. And the vehicle that we will be utilising for the NextETRUCK project is our DAF Electric XP, a picture of which you can see just there, and I'll show you a customer version of that in just a second. So it is a 19-ton vehicle. So here in the UK, we have a number of weight dispensations for zero emission trucks. So for a 4x2 vehicle configuration, just as what you can see on the screen there, usually for a diesel truck, you can go up to 18 tons in terms of total vehicle weight. In the UK, for a zero emission truck, you can actually go up to 20 ton if you're able to. For our XB product, the design weight of that truck is at 19 ton. So we can take advantage of 1 ton of that weight dispensation to account for the additional weight that we are carrying with the batteries as opposed to a diesel equivalent. At other vehicle weights also, there are a number of other dispensations as well. So for example, for a 3-axle rigid, so same vehicle as that with an extra axle and extra set of wheels on there, usually in the UK you can go up to 26 ton for that vehicle type, whereas for a zero emission equivalent you can go up to 28 ton as well, again accounting for the additional weight of batteries. So that's the vehicle we're talking about here for this project. That has 282 kilowatt hours of installed capacity on board, and we use 88% of that installed capacity, with a little bit at the top and a little bit at the bottom to account for regeneration and ensuring you're not fully depleting and fully charging that battery up every time to maximize the performance of the battery over time, which I will touch on. The vehicle can charge at up to 150 kilowatts through DC charging or 22 kilowatts through AC charging, and it has an AC charger on board. And I talked a little bit earlier about our production or assembly plant here in the UK, Leyland Assembly Plant. This vehicle and vehicles of its type, the XB, are all built exclusively here in the UK. So go into a little bit more detail around the vehicle itself. So what you can see here is the electric drivetrain. So the vehicle itself is built very much on the same concept and same chassis frame as our diesel XB, to support us with production and also parts availability as well if there are any issues with trucks when they're in service. But we have a centrally mounted drivetrain with a single speed e-motor that you can see right in the middle there. We've not opted to go for a kind of e-axle concept. We have got centrally mounted drivetrain with then chassis along the chassis rail, which I will touch on in a second, either side, with 2 options for our kind of motor, either our EXM1 or EXM2, based on the vehicle size and what kind of motor size is right for that specific operation. The battery kind of setup that we go for is, as I mentioned earlier, up to 282 kilowatt hours for our medium duty or our XB product. You can move those around slightly on the cab based on the chassis, based on how many batteries you have installed. If you have the full complement, the full 282 kilowatt hours, you're a bit more limited in terms of moving stuff around. However, we also have a what we call a C-pack, which is the next one down, where instead of 282 kilowatt hours, you instead then have 210. And we do also have a lower variant as well of 141 kilowatt hours installed, but that would be for very specific operations that maybe did not need to do that much range every day, and would be able to maximize on payload instead of range. The chemistry that we have opted for our batteries is lithium ferrophosphate, or LFP. A number of reasons for that. So propensity for LFP chemistry to withstand a large number of charging cycles. So with our batteries, we have a 8-year battery warranty, up to 4,000 complete cycles of the battery. So that is really to give operators confidence that that the vehicle is going to be performing well over a long period of time. What we also see, and one of the reasons for opting for LFP, is an ability to charge daily up to 100% via DC charging without an impact on the performance of the battery itself or experiencing undue battery degradation, as well as some other kind of safety benefits as well, such as propensity to guard against issues such as thermal runaway and other kind of safety features like that as well. So LFP is the technology that we have gone for. So coming on to the demonstration period itself, so we are working with one of our key partners, Turners of Soham. So they are one of the largest fleet operators here in the UK, and they run a whole host of vehicles, from smaller distribution type vehicles all the way up to the very largest trailers, tractors and trailers in the UK, going into Europe, going all the way around the UK as well. One of our largest customers. So Turners have a number of kind of operators that sit under their umbrella, and we're working with 2 of those as part of the demonstration period, with 1 truck being run by each of the 2 operators. So we have Shakespeare Transport, who are based close to London in the southeast of the UK, and we also have Matthew Cabell Transport, who are based in the northwest of the UK as well. And the picture you can see on the right hand side there is the vehicle that's in with the Matthew Cabell's transport operation, which is fully liveried. You can see some details on the grille there in the fact that it's blue, as well as on the right hand side there, just at the bottom of the door, XB, but also electric underneath it also. So yeah, they've had it all sign written, and yeah, those that know will know that that's a fully electric truck doing some key urban distribution. So I touched a little bit earlier that one of our key objectives for the demonstration period is to understand what the key factors are towards vehicle range and vehicle efficiency. And so I think it's always good to have a kind of hypothesis when doing these kinds of tests and trials. So our hypothesis is that I've listed there 4 of the key kind of contributors towards how far a fully electric truck will travel and how efficient it will be. And our hypothesis is that, in order of importance and biggest influence to the vehicle range, the first one is going to be the driver. So how the driver is driving the vehicle, how much they're using the regeneration through the vehicle and regenerative braking, and ultimately their kind of behavior when driving the truck would be the biggest factor. The second factor would be the temperature. So outside temperature and the vehicle then needing to either cool the batteries or warm the batteries up to the appropriate temperature and the energy that is used through that process. The road conditions being the third factor. So that is whether the vehicle's driving on the motorway or within a city environment or a more rural environment, due to the differences in needing for braking and cruise control usage and all of that kind of stuff. And then the fourth factor being weight. So how much weight the vehicle is carrying in total, because again, it's going to need more energy to carry more and more weight, and the kind of trade-off you then have on the range of the vehicle. So at the outset, those are the kind of, in order, the variables that we think will have the biggest impact. And again, as we then work through the data in more detail through the course of the demonstration, we'll then be able to test that hypothesis and see whether we were right or whether actually the order is slightly different in terms of what contributes the most to efficiency. So yeah, just to give you a little bit of an example of some of the early data that we've seen of the 2 trucks so far. So this is from the onboard telematics that's built into the truck. So on the left hand side there, we've got one of the trucks that's in more kind of inner city distribution. So starting a little bit out of the city where the depot is, traveling into the city or into a couple of cities with a number of drops within, tighter environments within inner city, and then returning out to the depot just outside the city at the end of the shift, and then repeating that process again for a second time during the day. So very much stop-start, very much within a tight environment, lots of traffic lights, lots of regeneration, all that kind of stuff. And then on the right-hand side there, we've got some of the early trips and routes through the second truck, which is more of a urban/rural distribution, I would say. So not so densely populated in terms of city driving, however, a little bit more of a longer drive into more rural locations. So maybe slightly less regeneration, slightly less stop-start, but maybe more cruise control usage. So again, that will be interesting to see how the two trucks differ in terms of their performance. What we've seen so far, so it's quite early days since we've started, just to get the vehicles embedded into the fleet, ensure that the drivers are trained, the charging is all set up. The total vehicle distance so far on each of the trucks is roughly 4,000 and 5,000 kilometers so far, with an efficiency roughly varying between 0.8 and 1 kilowatt hours per kilometer. So just to put that into perspective, an efficiency figure of 0.8 kilowatt hours per kilometer, which is basically how much energy you're using to travel forward 1 kilometer. 0.8 would equate to about 310 kilometers of total range if you went from 0 to 100% at 0.8 kilowatt hours per kilometer. 1 would be below 300. That would be into the kind of 250-ish range, and then obviously anywhere in between that would be in between the new figures. So what we'll be striving for throughout this is getting consistently around that 0.8 kilowatt hours per kilometer. And distance travel per day, is increasing, and what we've seen so far is from 50 to 105 kilometers per day in total distance covered, and we'll be looking to increase that through the demonstration period with both operators as well. Here you can see the charging setup for one of the trucks. So when we did the BET trial, which I touched on earlier, the vast majority of charging for those trucks was on AC charging, so slower charging up to 22 kilowatts, which would take in the region of 12 hours or so, maybe slightly more, to charge fully from 0 to 100%. What you can see on the screen is what we've seen a lot of interest in is around mobile charging. So you don't necessarily need the same level of infrastructure installation as you might need for high-powered DC charging, but that charger can charge at 40 kilowatts at DC, and all that is required is a 63 amp commando socket, which we have in the UK. I'm sure there are equivalents in other markets as well, which is a much lower cost installation to allow DC charging, and is especially convenient, especially when considering the total cost of ownership, which is another objective of the project. If you have a site or a depot where you may not own the depot and you might be moving from that depot to another one in the future, and you want to start your electrification journey, but you are worried that you're going to spend a lot of money on infrastructure that you may not then be able to take with you or recoup. So a mobile charging solution is a really good way to start on that electrification journey, keep the costs low, and start to reap some of the total cost of ownership benefits. So it will charge in about 6 hours from 0 to 100%. So very, very easily done overnight for one vehicle, ready for the next day's operation. And what we are also starting to see here in the UK is a slow adoption towards public infrastructure, so publicly available electric HGV chargers. So we're starting to see that more and more, and through the trial, if there are public chargers available in the route or near the route, then we could look to see if we can incorporate that as well. But depot charging is the it's a preferred route, and we've got a good solution in place with both operators. So what do we want to do further, you know, through the demonstration period now that we've made our start? So we want to be pushing the range further. So we have a targeted range, you know, achievement of 300 kilometers. So we want to be pushing the truck to its maximum to achieve that. We want to be looking at further driver training, so ensuring that the drivers are really getting the most out of the trucks and enabling 300 kilometers. We want to be making some tweaks to the operations themselves, so, you know, changing the drivers within the truck and also changing the routes themselves to understand what difference that has on the efficiency of the vehicles as well. And then we have a number of planning tools as well that will be integrated into the operations as well to, you know, again, optimize the performance of the two trucks. And then finally, you know, how will we be utilising the data? Obviously, the NextETRUCK has a number of objectives that Nicholas has talked about, but also from an internal perspective, you know, this information is going to be key to us to better support driver training and handovers for further electric vehicles. So if we have a really good understanding of what the key factors are to improving vehicle range, vehicle efficiency, then we want to share that information with other customers as well who are thinking about that, to ensure that any EV operator is getting the most out of their truck as possible. It's going to obviously support our future product development. So yeah, seeing the vehicles in real world conditions, getting some of that feedback from the drivers and from the fleet managers as well is going to support us develop our products further. And finally, it's going to allow us to showcase a positive TCO to other operators to again accelerate EV adoption here in the UK, but also elsewhere also, which is a key factor and key driver for the NextETRUCK project as well. So that brings my presentation to a close. Hopefully that has been useful. I think, sure you'll agree, it's an exciting project. We're working with some really key partners and looking to really get some valuable insights from the project as well. And yeah, we will be disseminating and sharing the findings as we find it over the coming months also. So I will see if we have any questions. Maybe there is.
Thank you very much, Luis. This was fantastic, a fantastic first insight. We do not have any questions in the chat yet, but I encourage the participants to put them in the chat. I have a question. Of course, it is very early in the pilot testing phase, but what did the users, I mean the drivers, and what did the logistics company said? Of course, there are no results yet, but was there anything that was complicated or surprisingly easy, or yeah, any news?
Yeah. So I went to visit Matthew Kibbles actually earlier this week, just to check in. They did initially, one of the challenges was around the charging. So, you know, ensuring that they had the charging in the right location, you know, ensuring that they had enough grid supply to enable a 40 kilowatt charger. So that took a little bit of preparation and a few bit of back and forth, but yeah, it wasn't too complicated really, because it's a as I said, it's a lower cost installation. Their feedback was from a running cost perspective. You know, they, especially with the current climate we find ourselves in, with fuel costs at the moment are very challenging, especially here in the UK. Then having an electric truck where you're in, especially when you charge at your depot 100% of the time, it's a much lower cost running cost versus a diesel equivalent at the moment. So they're very positive about that. And their feedback from the driver again was also positive. You know, he really enjoyed driving it, especially when you're in, you know, inner city environments with lots of stop and start. An electric truck, it has instant torque so that you can pop away very quickly, and yeah, it's a really nice driving experience. So yeah, a couple of challenges early on, but very positive feedback so far, which is good.
Yeah, this is basically what I've been hearing from all the drivers, basically. Yeah. So there's, of course, everyone is surprised how smooth these vehicles are going. I have one larger question that I'm quite sure you're not able to be able to answer. The first thing that you were mentioning about your big network of let's say workshops or checkup points or whatever you called it, because there's this huge requirement to regularly check the trucks in the UK. Do you have any knowledge about if the problems between the IC and the battery electric vehicles are significantly different? Because what I'm always hearing that battery electric trucks require, of course, less maintenance. Are there different maintenance rules for ICEs or BEVs, or is that the same, or do you have any news about the feedback of these checkups?
Yeah. So the trucks themselves are on the same schedule as a diesel truck. So in the UK, it's determined by the operator. So if the operator proves that they can run their trucks efficiently based on seeing them every 8 weeks or 10 weeks or 12 weeks, then that will be the same for whether it's a diesel or electric truck. From specifically to electric trucks, we have a specific service sheet for the workshops. So they have slightly different things to check with the EV. Obviously, there isn't an engine to check, there isn't a fuel tank or anything, but instead of that, they have batteries, they have an e-motor, they have different components. An electric truck has less moving parts than a diesel truck. So for a rough guide, a repair and maintenance package in the UK for an EV versus a diesel is about 10% cheaper, roughly. And that's because there are less components that are moving and friction within the vehicle itself. And yeah, the experience so far is, they're more straightforward to run. Obviously, the EVs are still relatively new in the marketplace, so there are other considerations for manufacturers around parts availability and ensuring that you have the right parts when you need them in the right places. So it's all of that kind of stuff that's being worked through. But from an operator perspective, they don't really need to worry about it so much. It's all on the same maintenance regime as their diesel trucks, and the repair and maintenance contracts are slightly cheaper as well, which is always positive.
Okay, great. Yeah, that's that seems to be also the same experience with what I hear from other OEMs from other countries, basically. Elisa, do you have questions, or otherwise I could also have another one.
No, from my side it's okay. You can go forward.
Also, I have quite a broad one. So basically, because the EU standards for heavy duty vehicles are going to be stricter than the ones from the UK. I assume if everything stays like it is one of the early slides that you've showed us. So will this then be a classic situation where the UK will have to follow the rules of the EU, because simply you're not going to build different trucks for the UK, basically, I assume. Obviously, I guess. Yeah, okay.
Yeah, so in the UK back in January, the Department for Transport launched a consultation around the regulatory framework for the reduction of CO2 and HGVs in the UK. And there were a number of questions within that. One of which is, or one of the options was to fully align with the EU on the targets that I showed on the slide earlier. There were also other questions and factors as well, because in the UK, for the passenger car and van manufacturers, we have what's called a ZEV mandate, a zero emission vehicle mandate. And that's basically an increasing target every year that the car and van manufacturers have to meet by. All of the registrations have to be a percentage of EV. I think last year it was around 25%, roughly, I think. So one of the questions was, should that be the same for truck manufacturers in the UK? So There are a number of options within that. So we expect to hear back later this year around what route the UK government are going to go down, because like you say, it will be, could be a challenging environment possibly, because we're all European manufacturers or mostly, so we're going to be building trucks and selling them in the UK, but also in the EU as well. So I think having some alignment with the EU is always going to happen. It's just whether the targets are the same, whether there are any differences between the UK and the EU, really.
Okay, that's very clear. I don't think that we are getting additional questions from the chat.
Yep.
So I think this is a good time to thank you very much, Luis, for these insights, and then I will basically communicate with you internally and the other partners to see which kind of trucks we can get to the final conference in Brussels. So then we can hope we can have the largest variety and maybe even have your truck there. So for those who are attending today, maybe you will have the chance to see that one in Brussels if everything works out. Let's see. And also, I would like to raise awareness for the other webinars. I will just briefly share my screen because we still have a couple of minutes, so you could scan the QR code in case it is still live. So you should be able to see my screen, I guess. So I will go back. So basically in a couple of days, we're going to talk to our partners from Xenex NL and UK. They have developed the TCO and the charging infrastructure tools. You already find information about this also on our website. And then 1 week later, on the 10th of June at 11 a.m., same time as today, we are going to hear from our colleague who's also here in the webinar, from Inigo Lama from IRISA, about the pilot results from Barcelona. And then if everything goes well, we have a German digital breakfast where Luis and myself and others most likely are going to present our progress on the heavy-duty vehicle electrification. There we need to see what the format will basically dictate and where we're going to focus a little bit, but where we also give some general info to a mostly German audience, but also some internationals are going to join there. So scan the QR code. I hope we will see each other soon. And with this, I would like to conclude and hope to see you in Brussels or elsewhere during upcoming events. Thank you very much again to Elisa as well, who supported me with the organization of the webinar, and Luis for presenting. And with this, I wish you a great weekend and goodbye.
Thank you very much. Goodbye.
Well, goodbye.